أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم class 12 physics. Our topic is we are discussing continuous charge distribution. Continuous charge distribution. Let us take the second type, surface charge distribution. Surface charge distribution. That means when a charge is distributed continuously over some area or some surface, that means, for example, or on a certain membrane. In this case, we use the term surface charge distribution or surface charge density. Surface charge density is defined as charge per unit area. Surface charge density is defined as charge per unit area. If a charge is distributed over a certain membrane or a certain surface, let us take this our surface having the area S. If charge is continuously distributed, we are taking test charge, this positive charge, it is continuously distributed over this surface having surface area S. The surface area is S. Charge is continuously distributed over it. Charge is continuously distributed over, we use here the term surface charge density. This surface charge density is shown by sigma. Sigma. This surface charge density is given by sigma. This sigma is the charge per unit area. Charge bata area. Charge is Q, Q bata area. Q area is S. This charge, this is surface charge density. Surface charge density. And this process is called surface charge distribution. Surface charge density is charge bata area. And we know that for area we have length over length. So we can see Q is equal to length over length. So for Q we have unit column, for length we have meters over meter. So we can say it is unit for surface charge density is coulomb per meter square, or we can say coulomb meter minus 2. Okay. It is measured in coulomb per meter square. But surface charge density. If charge is continuously distributed over a membrane of surface area S, we can show it by coulomb meter inverse. Okay. The surface charge. Let this charge is not distributed uniformly over the surface. Let's consider it is not. For example, at some surface it may be having, like let us take a small surface of area ds. So we know that it is charge may be dq of this surface area, that it may not be distributed uniformly all over this surface. Okay. Let us take here a test charge Q naught the effect on this Q naught due to this charge element ds with charge dq, the effect on it would be either rather interactive force or repulsive force. That force we may show by df. And the distance between these two charges, what charge? Charge dq, have the charge element, this charge element that is having a charge dq, and this charge, the distance between is shown by the position vector r. And we know that we are showing this is our unit vector r. R, its value is 1. Its value is 1. So we know that this here we know sigma is equal to Q bata as here in this charge element, the sigma would be dq bata ds, or sigma ds would be dq. Total charge all over the surface, that may be dq, all over the surface, all over, we are taking here s, all over the surface would be, that may be uh, sigma ds, or it may be cancelled, it remains only q would be all over the surface sigma ds is the total charge all over the surface. It is total charge all over this surface. But on this surface, the charge was this dq, that is equal to sigma ds. That is equal to sigma ds. There again, there would be a force of interaction between this charge element dq, this the surface element ds having charge dq. This, so we can see the surface dq, surface ds, and this q naught. There will be a force. That force we may show as df. The force is not between the surface element and the force between the charges, either attractive force or repulsive force. We are taking, this is a test charge, we are always taking positive, this positive, so it may be repulsive force. So this df would be, this df may be, we are taking the d by Coulomb's law, it may be q naught dq, q naught dq divided by 4 pi epsilon naught r square into r cube. It is our this force. Now total force on charge q naught is given. It is a sum or fraction of force. Now total force. We may opt to getting total force by integrating this df is equal to integral of q naught dq divided by 4 pi epsilon naught r square r cube. But this may be all over the surface, over the whole surface. Okay. So this df would be is equal to, we may take q naught 4 pi epsilon naught outside. Instead of dq, we have already taken before, but that's about sigma ds. Instead of dq, we can write sigma ds divided by r square, r over the whole surface. After integrating this df, it is integral here. If we integrate this, it may remain only f. It may remain only f. So f is equal to q naught by. So we are getting total force. Total force f is equal to q naught by 4 pi epsilon naught integral of s sigma ds divided by r square into r cube. Okay, this is the total force on this charge element due to this surface, or any type of membrane when the charge is distributed non-uniformly over this surface. We get this. Okay, it was all about of this surface charge density. What we have found it, when the charge is distributed continuously over the sum area, e.g. a membrane, any type of membrane. In this case, we use the term surface charge density, which is defined as the charge per unit surface and is denoted by sigma. Sigma is equal to q by s. However, in case of when the charge is not distributed over uniformly over the surface, then we get this force like this. We have found the force between this charge, we can say charge element ds and this q naught, that is equal to f by 4 q naught by 4 by epsilon naught sigma ds by r square, because this charge dq, it is equal to this sigma ds. We have found this, and if we know that it is area, and we can find this force. We can find this force.